Namaste, sir. Can we start, sir?
Yeah, we can start.
Okay. Thanks. Namo Namaha. Swarupa Parama Jyoti Rupa Sanatme Sarva Vidyadhi Deviya Sevanye Namo Namaha. I welcome you all in the third lecture of the series of Sanskrit Saptaha organized by Department of Sanskrit, University of Mumbai. It's our great fortune that we are listening to two devotees of Goddess Saraswati in this Sharadiya Navaratri. Yesterday we heard enlightening lectures of Professor Abhiraj Rajendra Mishra and Professor Brajakeshwar Swami, who have literally kept Samskrita Mandakini flowing with their consistent effort. Today we have renowned scholar Professor Girishnath Jha as a speaker who has immense contribution in the field of Sanskrit computational linguistics. Professor Girishnath Jha is a professor of computational linguistics at School of Sanskrit and Indic Studies, Jawaharlal Nehru University, New Delhi. He is currently chairman of Commission for Scientific and Technical Terminology and chairperson of several professional and educational bodies. He was international visiting faculty at many universities, including University of Würzburg, Germany, University of Florence, Italy, Yogyakarta State University, Indonesia, University of Massachusetts, USA. He has given consultancies to many professional organizations like Google, Nuance Communications, SwiftKey, Microsoft. He has almost 285 talks, plenary sessions, etc. at various 138 research articles and papers, and almost 12 books to his credits. 40 students have obtained MPhil degree and 30 students have obtained PhD degree under his able guidance, and some are definitely still in progress. He has received several honors and awards, to name few: Dattapeeth Asthan Vidwan Award, KECSS Felicitation Award, Dart Fellowship from Germany, etc. etc. We have such a renowned scholar and stalwart with us, and he will speak on very important topic, which is for today's era, that is Sanskrit computational linguistics. This topic is Sanganakiya Bhasha Vigyan Mein Pravidhigat Navachar. I extend warm welcome to you, sir, and well salutations. I ask you to deliver your lecture. Thank you.
Thank you, Shakuntalaji. Can everybody hear me well? Okay. Thank you, Shakuntalaji, for inviting me to this very important series. संस्कृत भाषायां गति नास्ति धाराप्रवाहेन वक्तुं न शक्नोमि शनैः शनैः वक्तुं शक्नोमि अत एव आङ्ग्लभाषायामपि वदिष्यामि. The topic which I have selected, I thought, because you are Sanskrit faculty members, being oriented or refreshed in a certain way, and we are celebrating Sanskrit Saptaha, right? So I thought something which will be kind of new to you, and perhaps will inspire some of you to actually consider this when you are either teaching a course of this kind or a student. So let me very quickly share a screen. So can everybody see the PPT here? Right. Is the PPT visible to everybody?
Yes,
Hello.
sir.
Right.
Yes,
Great.
sir.
And you see it changing also. Badal bhi raha nahi hai? Okay. Is it changing?
Yes.
Okay, great. Thank you. Because so happens that sometimes, the lecture goes ahead and PPT is not changing. So that creates a lot of difficulty. Okay. So the methods have changed. The methods of, Sanskrit, empirical studies, linguistics, empirical studies, or AI, and they have evolved dramatically. And I'm going to focus on some of the aspects that I'll be covering today on that. And then also talking about how we connect to the emerging areas of information technologies, how we connect and where we are placed actually. Starting with the central idea of artificial intelligence, to just give you a little bit of background, I will quote John McCarthy, who actually coined the term AI in 58 in a Dartmouth conference. And he says AI can only happen if machines understand natural language text. So AI actually means understanding natural language. So in a way, natural language processing is AI, computational linguistics is AI, because the goal is to make sure machine understands natural language text, right? प्राकृतिक भाषा में जो टेक्स्ट है उसको समझ पाना मशीन के लिए आवश्यक है AI होना है तो. But natural language texts are so complex, because they have layers and layers of meanings embedded in the text. Those embeddings have to be unraveled to get the meaning, and meaning is not necessarily coming from the words themselves. Meanings might be outside the sentence completely, right? So what is being said in a sentence or phrase or a word and what exactly it means may be completely unrelated. Linguistically, it might be determined by the context completely. So pragmatics also becomes very, very important. And the whole area of the intelligent computing has been conceived from the point of view of building natural language capability in the machines, building a dynamic intelligence capability in machines, just like as we do. And most of our intelligence, we don't know whether the intelligence that we display in our communications or our behavior is actually stored in natural language in our brains. We don't know actually. Perhaps something interlingual, something beyond or between two languages, something like that is the formation where perhaps intelligence is encoded in our brains, and something like a mathematical language, that our Nayayikas have, Navi Nayayikas, etc., have indicated, later, that this might be possibly the scenario, and what the grammarians, linguists in the West have been talking about, and the logicians have been talking about, or the AI people have been talking about, something like an unambiguous mathematical representation of a language is there in the brain. So the whole idea of intelligent computing, right from the 40s, where encryption and decryption. I've taken this slide from one of my friends in Germany, Jeff Gibbon. Encryption, decryption, encrypting a message so that whatever is encoded can only be understood by the person who knows how to decrypt it. So if I'm speaking in English language right now, so I'm encrypting my meanings in a nuanced language grammar, which is called English grammar, and your brain is able to decrypt it because your brain has the same algorithm application capability in reverse. If your brain does not know how to decrypt what I'm saying, it will not be able to understand, right? So natural language sentences are basically encryption and decryption. So communication, encryption, decryption. And that was tried in the Second World War, and because of make sure that the communications are kind of secure, over on such a network, and it reaches to the target audience in a safe manner. And similarly, they started talking about neural automata, neural networks, and neural linguistics in the 40s. 50s was the decade of actually machine translation, where a lot of projects were given in America, and they thought, if we are able to, capture Russian text in English, we have to have a Russian to English machine translation. Similarly, English to Russian. There were Cold War actually going on after the war. 50s still there was a review, and people say machine translation is too difficult. AI hasn't come yet. Right? AI comes in 58. The name comes in 58, but the AI activity was machine translation was the main activity, and they thought machine translation is not possible, and so they kind of rejected this idea of humans, being done by a machine in the sense of translating text. 60s, we went into theoretical informatics, natural language, complexity, parsing, etc., etc. Was the highlight of psycholinguistics came to the fore, because in 72, Prolog, the language of logic, programming in logic, was discovered, was invented, I think in Stanford University, if I'm not wrong. And then Prolog became a fashionable language to do in 80s and 90s. And I learned Prolog 80s and 90s. And when I did a course in AI at the University of Illinois in 1997, it was actually a course in Prolog and Lisp. Right. With 2000 century, the AI took a sudden turn towards what is called the language informatics-based computing. So we became data-driven. Data-driven. Suddenly, a lot of data became available. We started talking about big data and big linguistic data, which would basically train the large language models. So it has been seen in the field of AI, and where we will go in next 10 years, it's not certain, because the evolution will be much faster in next 10 years or so. So if you look at basic areas of AI, you do computational linguistics, NLP as a core meta discipline, which underlies all of them actually. Language processing is the foundation for all AI subdisciplines, like inference engines. We make inferences. Expert systems are basically experts in one knowledge field. Intelligent tutoring systems are kind of educational technology, one-to-one tutoring machine, which deal with you one-to-one as a teacher, teacher and a student kind of scenario. Vision machines interpret images. Images could be written documents, handwriting also, and signboards, etc. So all of them actually involve language in a certain way. Robots are machines which receive commands in natural language. So natural language is there, as well. And so AI is basically synonymous today with machine learning. And no matter which method you use in AI, whether you use the classical grammar method and the linguistics method, dictionary method, or you use machine learning or the corpora method, machines have to understand natural language communication. How you make machines understand, that's another question. So methods have changed, but the goal is the same. Goal remains the same. But we have gotten more successes. Machine translations have become more successful in recent years, and so have become other areas of AI. We have achieved a lot of successes in other areas of AI. So there are success stories in AI. So if you kind of human-computer intelligent interaction, and talk of computational linguistics, where we are, you can see. So HCI basically is an area where we think of more and more intelligent means of communication with the machine. So there's a conventional AI, we think of keyboards, at the most smart keyboards. But when we talk of HCII, we think of communicating with machine just like human beings communicate among each other in natural language communication. When we are able to communicate with machine in natural language like humans do, we consider machines intelligent, and then we say this is an intelligent interaction mechanism with machine. And the major objective of course is to make languages be understood by the machine, so that we can communicate in languages with the machines. So this brings us to the question, how is linguistics meta-discipline in AI? And the reason it is a meta-discipline is because languages have layers of sounds change, words, and words change, and words have structures. And so the sentence formation also is dynamic, and the meaning determination dynamic. So all these layers of structures in a typical natural language communication, and those have to be unraveled, understood, not without linguistics. So if you don't do linguistics, core linguistics, you cannot unravel this structure which underlies this dynamic behavior of sounds, words, sentences, and meanings in natural language. So therefore, linguistics becomes the fundamental discipline. Another question is, if linguistics is the fundamental meta language or meta discipline in all AI, where does Sanskrit fit in? And Sanskrit fits in because in linguistics, the first core discipline, core text that is considered core work in linguistics, core work in core linguistics is Panini's Ashtadhyayi. And Panini's Ashtadhyayi is studied in most linguistic departments, most good linguistic departments. I was in Florence University, a visiting professor, and the linguistics department there teaches Ashtadhyayi. I was in University of Illinois, Urbana-Champaign, they teach Sanskrit there. And of course, Ashtadhyayi, they refer to Ashtadhyayi and they kind of glance on Ashtadhyayi as well there. So Sanskrit has been a core subject in linguistics departments in many countries. Of course, may not be that so in India, but in many countries, Sanskrit has been a core discipline in linguistics department. Certainly in other departments also, but Sanskrit has been core in linguistics for sure. Because there has been a huge linguistic tradition, or I should say, the tradition of linguistics in India. Doing linguistic studies, linguistic analysis was core to the Indian intellectual tradition. Why? Because we wanted to do everything in oral tradition. And to do things, to construct text in oral medium, oral tradition, we have to be good linguists so that we construct entire knowledge in Sutraic tradition, Sutraic fashion, in Chandas, so that we can remember entire Vedic texts in songs as songs. You can remember entire mathematical texts as songs. You can remember entire Panini's grammar, 4,000 sutras as a song. So Panini's grammar can be sung in 2 hours. You can sing the entire Panini's grammar in 2 hours. So this has to have a very clear way of constructing these unambiguous sutraic statements. And the whole idea in artificial intelligence is that how we can convert a natural language, dynamic, creative communication into a form which is unambiguous, sutraic, and very precise. And that exercise, fortunately, was being done in India for a different purpose, right? And that the evolution of linguistics is a major area in India, and therefore the Vedangas, 6 Vedangas, 4 actually are the linguistic studies. So there was I would say a lot of weight is given to linguistic studies and analysis in India because of that. And if you may have known this paper by Rick Briggs, this Sanskrit an AI paper. I to read these papers. It's an article which came in AI Journal in '85, and which basically says that in the AI community should be happy that in India people have been doing something similar more rigorously, and it would be nice that AI community understands what they're doing and then start from where they have stopped. Otherwise, you'll be reinventing the wheel again and again. So therefore, the AI kind of research that India has been doing for practical reasons has to be understood by the West. Therefore, it calls for a good communication between Sanskrit scholars and the Western AI researchers, linguistic researchers. And similarly, a paper by Nicholas Osler, where he talks about Sanskrit studies as a foundation for computational linguistics. And when you say computational linguistics, it means using AI. Sanskrit actually is foundation, Sanskrit studies, and he has his argument. So, and you should perhaps try to read this also and see why Sanskrit studies should be isolated from such innovative areas. And the new education or national education policy talks about ending the isolation of Sanskrit and try to connect Sanskrit with other multidisciplinary areas of study, and therefore this will be an important paper to actually go. Now, coming back to three people who actually shaped these studies, and therefore in the process the methods also got shaped. And these are, of course, I mentioned Panini, 7th century BC. He shaped these studies in a major way, and he's still being studied, and he's still influencing, be it methods in programming, methods in AI, and methods in other cognitive studies. Panini has been influencing all these. Saussure studied Sanskrit. He taught Sanskrit for 30 years in Geneva, and his PhD was actually on Sanskrit genitive. And he influenced studies in his own way, particularly the science of, I would say, linguistics, of course, and then semiotics, and Chomsky, all of you know. So why is Panini important in this area? This view of his grammar consisting of 4 modules. If I'm looking at a functional AI system, which perhaps underlies human brains, linguistic capacity, that can be understood in as a modular system, which has 4 modules, and not necessarily one preceding the other, but they all interact with each other in their unique ways, right? I wouldn't say Akshar Samamnai, the sound module precedes the sutra part, not necessarily. They perhaps do parallel process, something like if you open the old watch and see the different wheels interacting with each other simultaneously. It's like an engine, actually. So the fact that I'm talking to you in English language, your brain has some mechanism to handle English language, and but to do that, your brain must have the sound component. You must hear the sounds, and those sounds must be translated or transcribed into the language written form, and then the grammar comes in and does the work. So Akshar Samamnai is the starting component. If this module of human brain, the hearing capacity, is damaged, you will have no language, right? So when children are born, they bust as the hearing capacity of the children. So this is the hearing capacity. Hearing is complex. Hearing is not only hearing the sound, but be able to parse the sounds into writing correctly. So something similar, like in Google Assistant, a speech assistant, when I speak to Google Assistant or Siri, they are able to write it out. So that part. And then once it is written, then the language processing part actually starts applying. And then we have Sutra part, which has 4,000 or so rules of grammar, nicely arranged, like an ek vakya, from beginning from Vridhirades to and then its own mechanism, and all of them, they apply in a certain optimized way. The rules are sequenced to give optimum outputs. By the way, there is a theory called optimality theory of syntax and phonology, and this book, I think, came in 1996. Perhaps Prince and Smolensky are the authors of this book, Optimality Theory, and they have a big chapter on Panini and phonology. And Panini and phonology, they say, has inspired this whole idea of arranging the rules of grammar in such a sequence that what comes out of the mouth is the optimum output. What is optimum? Which is acceptable in society. Chomsky also talks about the utterance which comes out of the mouth must be tested in the society. If society accepts it, that is the optimum output. And to do that, brain constantly is trained by trial and error and learns how to sequence the rules in a certain way that the only optimum output comes out. And the generative grammarians have been talking about that, in a different way, and I'll be discussing that. Now, each functional program and human brain is the biggest program ever written. Each functional program, even today, works on databases. Talk about any computer program, smart program, they have the smartest of the program is determine how smart database you have. And Panini's grammar has a two big databases, and first is Dhatu part and Gana part. And incidentally, I realized that Dhatu part, the word sounds similar to database. The database and Dhatu part may be cognate. Cognate is from the same source. So Dhatu and data, I think Dhatu and data are cognate too. The word Dhatu and data. datum, and dhatu. So Panini's dhatu part is external. It's not part of the sutra part, and so is in any good program today. You will not have database inside the program. It's always external, and the program makes a reference to the database, right? Like Panini said dhatu, and the entire database becomes internal. Similarly, a computer program will make a reference to the database by establishing a pipeline and connection, and then execute queries on that through the pipeline and get the database. Unless I set up a pipeline between the program and the database, I can't send the queries, I can't get back the data from the database, right? So that's certainly there. Right. Now, similarly, Gana part also, and then we have lists, and the smaller lists, which can be handled by the program, which can be handled inside they are always internal to the program, and so has Panini done. So in a Panini's four modules, of modularity of Panini's grammar mimics human brain, and therefore the computer programs have always been inspired by this, because computer programs always mimic human brain. So therefore Panini's modules in grammar have been a good inspiration for all smart programmers. So Panini system is actually more formal and I would say largely unambiguous, because not everything is completely unambiguous in Panini. Panini has ambiguity. Panini has duplicacy, two rules applying at one point of time, and he has a certain unambiguous routines which basically will apply in a certain sequence, and you'll get optimum output. And to remove ambiguity, he says, viprashadhe param karyam. If two rules apply simultaneously, the one which is later, slightly later, has the force. There's a force of saying that the one which has come later is the correct output. They may not be so. But in a program, in a heuristic program, sometimes we do that. And in AI also, we have to take a call. If there's ambiguity, we take a call. Whatever is more popular, more frequent is the result. That's what we say, in a statistically trained machine learning algorithm, right? And in good programs, we have nice structures, organizations, precedence, dominance relations, etc., etc. And then we have variables, global variables, local variables, stronger variables, weaker variables, and they are all instantiated. And then we operate variables on variables. For example, instead of saying that the vowels are etc., we say vowels are ak. And so ak is a formula which will obtain its list by running, Adi Ranti and Sahita, by going through Adi Ranti and Sahita, running on a lattice of 14 Seva Sutras. So lattice of 14 Seva Sutras, when this Adi Ranti and Sahita operates on it, then the ak variable gets its list. So ak is a dynamic listing. It's a non-monotonic list building. So ak will get its value when this Adi Ranti and Sahita will run on the lattice. 14 Shiva Sutras. And these are called smart programming techniques. So if you hard-coded list, that's not good programming. Nothing is hard-coded. You get your list by dynamic running, executing the formulas. Similarly, the rules and replacement procedures of the AI context-free grammar mechanism may have been certainly influenced by Panini's techniques. And how Panini's techniques reached West because of the successive translations of Panini's grammar by the Western Indologists. Let's look at some of the famous quotes of Panini. So Bloomfield, again, I would say before Chomsky, Bloomfield was a major Paninian, because in his introduction, the famous book called Language, the book is called Language. In the introduction, he, in fact, all Sanskritists, I recommend all Sanskritists to read that book. It's been published also by Motilal Banarsidass in 1935 or something. You can, or maybe 1940s, but book is 1929, called Language. And I'm sure someone would have translated that also in Hindi. Please read that. He says that the descriptive grammar of Panini. He says descriptive grammar. People have criticized Sanskrit grammar as prescriptive, but the father of American structuralism, Leonard Bloomfield, he himself says that Sanskrit grammar is descriptive, is not prescriptive. Very clear descriptive grammar. And this grammar existed before Panini, but Panini brought a version of it to its perfection. That grammar which Panini brought is to its perfection is greatest monument, one of the greatest monuments of human intelligence, and an indispensable model for describing languages. The second part is more valuable to us. He says, you describe any human language. He doesn't say human language, any language, artificial language or natural language. Describe any language, Panini's grammar is indispensable, a critical model. Now, think of linguistic departments in India. Panini's model is not used in most of them for describing. Linguistic departments, they do field work to describe languages. And they do not use a Panini's model there. They instead use Chomsky's models. And that's quite sad, you know. When Chomsky's, the traditional precursors of Chomsky's works have been saying that, yes, Panini's grammar is indispensable. Similarly, encyclopedia would say Ashtadhyayi distinguishes between usage in the spoken language, Laukiki, and usage that is proper to the language of sacred text, Vaidiki. Ashtadhyayi is generative as well as descriptive. Now, encyclopedia adds another term, generative grammar, is much more technical. And with generative, we say generative grammar concept was kind of matured with Chomsky. But Chomsky himself says Panini was a generative grammarian. In his book, Aspects of the Theory of Syntax, in 1957 or 65, I'm forgetting, he says Panini was a generative grammarian. So it means Panini is the first generative grammarian. There's nothing before Panini. So if he says the Ashtadhyayi is generative as well as descriptive. Generative is much more formal, mathematical, than being just a descriptive. With this complex use of meta rules, transformations, and recursions, these are essential programming techniques. The grammar in Ashtadhyayi has been likened to the Turing machine. The Turing machine is a mathematical model of computer where the creator has described how this machine should behave when it processes an complex input to its ultimate output, and how this machine can be intelligent. How can it be called an intelligent machine? It says it has been likened to the Turing machine, a mathematical model that reduces the logical structure of any computing device to its essentials. What does Ashtadhyayi do? It takes Bhavati and keeps on doing, processing till you have gotten the essentials, which cannot be further processed. So there, the processing will stop. Bu, Shap, and Tip. The process stops there. And so does a computer do. The moment you get a complex input, the machine will start processing it and keep on processing ultimate outputs, and the process will stop there. The way computer processes, the way Panini does derivations in his grammar. Therefore, Panini's derivation mechanism, which he tried on a much more complex input like natural language. Before Panini, it wasn't considered that you can try computers on natural language. You can try computers or any mathematics on natural language or literature. With Panini, the idea came that yes, we can try computers, mathematics on natural languages too. So what Panini did was a much more complex task, which we are still struggling to achieve in artificial intelligence. Right? Now, Muriel Williams. It's important to understand these quotations, what exactly they meant. He says, that Panini gave a concept of meta-language and constructed 1,000s of years before computer scientists began exploring the same idea, the meta-language, meta-rules and meta-language. Now, nothing happens without meta-language. Our grammars, the grammar that we have words and other categories which hold these words. We have Rama and we have Sangya also. We have cup and the tea, the holder and the held. So the meta-language, the concept of meta-language, the categories, and much more abstract categories of meta-language have been discussed in Panini. Much more abstract categories of meta-language discussed in Panini. He said, this is what we do in computer science. A program is considered smarter if you have done more functions and more classes instead of doing context-specific computing, we do context neutral computing. If you have done context neutral computing, which is basically classes and functions which apply across contexts, these are considered better instead of writing functions for everything, which is considered weaker programming. So what Panini has done, of course, our goal was different because we had to do everything in oral tradition. What Panini has done, the way Panini has come to us, is a much more sophisticated program than I have seen anywhere so far. My company in America, called me exceptional programmer. I have no degree in programming, no degree in computer science. I'm a linguist. I have 2 linguistics degrees, one from JNU, one from Illinois. But my company called me exceptional programmer, and I have not found any program better than Panini so far. And I can appreciate Panini much better, as a programmer. So why is Panini important to computing? I have actually already spoken a little bit. Explicit formal mechanisms to describe almost anything. This has happened in Indian tradition, including the most difficult natural languages. Before Panini, this idea wasn't there. I mean, West got it in the 20th century, and we got it 7th century BC in India. Even before Panini, 10 grammarians actually tried writing grammars. I'm sure they would have done something which Panini brought it to completion. So India was much more empirical from a very early date. So Panini has impacted core areas of linguistics and computing. And let's look at some of the examples which I have picked up from Panini as examples of sophisticated, very high-level programming. If I would alert some of these techniques. He says generating dynamic lists on the fly. So lists are to be on the fly. Just hang on a second, I have to do some important activity. Sorry about that. Some important letter has to go to minister today. So, right. So, why generating dynamic lists are important? For example, storing data in database. If I have to say, for example, store, all the keywords from dictionary. Our organization makes dictionaries. So there are 2 ways to do it. We have experts. Experts will look at the books and identify keywords, which are to be the head words for a dictionary. Other idea would be to just run a program on a corpora. Corpora is an expression of the knowledge in that domain. So we have to make a dictionary of physics. So I run my program on the physics documents, and the program itself creates a list dynamically. This one, the second one is smarter, saves efforts, and it reduces the cost, right? So anything done dynamically is much more of value, much more valuable. And Panini does that. Adhikar, it's like, code using code blocks. If I'm a good programmer, I will describe my code that, okay, now I am doing this. From here to here, I have discussed this. From there to there, I have discussed that. So that if I'm a programmer, I leave the project, a new programmer has joined in my place. When he sees my code, he's able to understand the code nicely. So I compare Adhikara blocks and counting in programming. Anuvritti are iterations and recursions because we iteratively call a function within, and these are smart techniques. Paribhasha are and Sangya are the instantiate variables, and Dhatu part, of course, the database. And our Dhatu part is much more complex. But the important thing is that the structure of the Dhatu part is known to the Sutra part. If Sutra part does not know the structure of the Dhatu part, then the calls that it makes to a specific Dhatu will not be possible. Sutra part knows that what is the structure of the Dhatu part. The Dhatu part has 10 ganas. And each gana has certain semantic categorization. And where is the position of each Dhatu in that gana? It knows it very well. And so does a program today knows the structure of its database. Otherwise, there'll be miscommunication completely. Look at the close patterning of programs as per Panini. Singha Sutras are variable creations, identification, etc. They're extending the scope of a rule. Kartu ipsitamam karma, then tathayuktam chanipsitam. What is karma? Karto ipsitamam. But if something is included, gramam gachan trinam isprishati. Odanam bhanjana visham bhangte. So if something is, that also is, so I'm extending the scope of this rule, kartu ipsitamam karma. With the, is the actual process, and with the actually triggers, we have entire samagri collected. And actually in our puja paddhati also, we do all the samagris first, and then we start the vidhi. It happens, and all the samagri must be collected. All the resources for vidhi must be there already. Therefore, if there is a vidhi sutra akasavarna dirgha, for example, all the nuts and bolts which require akasavarna dirgha to be successful have to come before akasavarna dirgha. So savarna must be defined, dirgha must be defined, ak must be defined before the akasavarna dirgha is called. And this is exactly what happens in programming also. Niyama basically restricts the scope of a rule. We do exactly the same. And Nishadha, the proscription. This is not going to happen. So exceptions, exception handling, etc. in programming. And how Panini's grammar is how sutra is computed, So in a typical AI program, the classical AI, now the difference between classical AI and the contemporary AI is that in the classical AI up to the 90s, we provided programs, and then data would be read, and programs will process data. And programs included grammar and the lexicon. Right? In today's machine learning, we do not provide any program. Machine builds a program based on the corpora that it trains on. So program is the output of the machine. And we give the corpora as input to the machine. So in either way, we have to first, whatever we are going to write a program, whether we write the program directly or indirectly, we have to understand the task. So here we have to understand what exactly this rule is about, and whether this rule can be programmed or not. So tasks are of two kinds: programmable tasks and unprogrammable tasks. Not all the tasks can be programmed today by programming language. Right? Most commonsensical tasks cannot be programmed by computers today. Right? We have to understand if the task is a programmable task. And then we generate a pseudocode. The pseudocode is basically understanding the task and writing step by step what can be done. For example, if there's equal yanachi, so I first define equal yanachi. The re is wrong re here, and then we define the steps 1, 2, 3, 4, whatever the steps are necessary to solve that a finite state set of tasks. So the first step, for example, to solve this in Shiva Sutra, we define Shiva Sutra and then give Shiva Sutra each complex variables like ik, yan, ach, and we get list. And then we, after all the lists are obtained, then these lists are dynamic. We are obtaining by running the Adir and Tasayata on the lattice 1 to 14 Shiva Sutra, and then ach gets its value, and ik gets its value, yan gets its value. After all these values are obtained, we are ready to do the rocket launching. We fire the trigger, we fire the program. It says ik will become yan in the context of ach. And then, we start algorithm. Algorithm is if in any arbitrary thing like prati eka. Prati eka, this is arbitrary string. We find ik in the string, right? If yes, continue. Then search ach in the right context. Ik is found, search ach in the right context. Continue. Then replace each ik with the yan. Replace each ik with the yan. Yeah. So replace I with ya, E with ya, and you get pratyeka, and then display result and quit. This is how Panini's thing will work. And then next step is basically this idea. This pseudocode has to be converted to a programming language code, whatever language you know. For example, I know Java, etc. I convert this code into a Java code, and Java code, of course, will be a big code which will not only work for this single sutra, but all other sutras. And the code is then compiled and then we execute. We execute this code either on with an interface, programming interface, or without interface. Command line execution could be there, or with interface. And then you basically write, we say and then you say this thing is generated. Prati eka. This will generate pratyeka. Now, if I give this pratyeka to the processor, then it's going to give the result also. So you get outputs prati, the long, because prati is a word in Moni Available Dictionary, and prati is the short, both outputs. If you see how this output has been constructed, you run the program again, and it goes through all possible sutras of Sanskrit, that Sandhi sutras, and then at each cut, basically it applies the Moni Available Dictionary of 200,000 words. See whether each cut is a valid cut, and finally you get, it says it ends up that Yanachi is a sutra. This because this is also a word in the Moni Available Dictionary. This is how it works. So this is how is the program cycle, how we develop a program. The reasons why the departments of academic institutions have failed in this area, because they are not software persons. They can do the research and do a prototyping, and that to transfer to technology to the industry to do a software cycle. And this is the problem. We have not been able to get good faculty from the industry who have done programming. That's the problem. Ferdinand Saussure, the next great guy, who actually was a Sanskritist, and I call him a Paninian. He was a linguist, and see, his PhD was in Sanskrit Generative Absolute. And he lectured Indo-European linguistics and Sanskrit for 30 years. And his students published his lecture notes in called Course in Linguistics, And he was influenced by Paninian theory, and his idea on signified was influenced by this photo. And with him, there came the idea that formal rules can be applied to areas outside mathematics and logic. We can apply formal rules to language, literature, etc. The idea to the West was given by Saussure, and here Noam Chomsky currently shifted to Arizona University. He was in MIT since '55. Just 2-3 years ago, he shifted to University of Arizona. And he is known for universal grammar, transformational grammar, cognitivism, and nativism, are similar to our Samskar theory. And he successfully destroyed the behaviorists led by B.F. Skinner. He was a Harvard professor. B.F. Skinner was a Harvard professor who, in his time, the behaviorism was a popular theory. And he said, even language learning is behaviorism. People learn language by behavior. Even animals can be taught behavior, human language. So there were a lot of experiments, dog experiments and parrots experiments that he did. But when Chomsky basically joined MIT, he started working on formal aspects of language, his syntax and aspects of theory of syntax, 1957, then syntactic structures, and then successive theories of Chomsky all the way up to 90s. He firmly established a certain brand of linguistics I call it structural formal linguistics. And in his dealings, you see a very close parallels of Panini. And he created a hierarchy of formal grammars, type 0 to type 3. Type 0 is unrestricted phrase structure grammar. Type 1 is context-sensitive grammar. Type 2 is context-free grammar. And type 3 is irregular grammar. And context-free grammar is used in compiler design. And you see how context-free grammar, I'll show you, is very close to Panini's system. If you compare Panini's grammar with Chomsky's grammar model, you find amazing similarity. I just call it lifting of the ideas from Sanskrit and presenting it in a new dress, new avatar to the West. And I'm sorry to say, but some of the scholarship of the West has been very smart in copying things from here and there, not giving due credit. They give some credit, but not the entire credit. So 2 books, Syntactic Structures in '57, and then Aspects of Theory of Syntax, '65. These 2 books of Chomsky led to a model of a human grammar that maybe in the brain, he calls it language acquisition device or universal grammar. He says the grammar has a base component, a transformational component, and there is a deep structure that base component actually lands up in, and from deep structure we transform. So his base component, he says, grammar has a phrase structure, rules, and lexicon. This is very close to Panini's Sutra part and Dhatu part, Gan part. So Sutra part here and Dhatu part, Gan part. These three is his base component. And this, he says, it gives analysis, which is called deep structure. Deep structure is, again, we can so go deeper, you get Karaka component. Yes, this is Panini's Karaka and Chomsky's deep structure. And then you apply transformation or derivation process starts from there. And finally you reach to phonological component, which is Akshar Samavanai. Akshar Samavanai. So Chomsky's grammar also starts with phonological component and phonological component. Because a human communication, I speak and I hear. I speak and I hear what I'm speaking. And when you say also I hear. So hearing is very important. So therefore sound component is very, very important in a communication strategy that human beings have. If you compare Panini's grammar with type 2 grammar, which is Chomsky's formal grammar, which is used in compiler design. So Chomsky's formal grammar, type 2, called contextual grammar, is an abstract symbol G, which is a collection of non-terminal items like noun, pronoun, adjective, etc. Terminal like words of the grammar, Ram, Shyam, etc. And production mechanism, the direction of production, and start symbol. Let's look at each one of them. So V, which is non-terminal in traditional Chomsky terminology, would be noun, phrase, verb, phrase, determinant, noun, verb, etc. In Panini's terminology, of course, we have Sanya, Sarvanam, Kriya, Nam, Akhyat, Upsarga, Nipata, but something more abstract like Aka, Savarna, etc. These are also Panini's non-terminals waiting to be deciphered by running a formula. It's much more abstract, another layer of abstraction. But I'm saying that the Panini's grammar is much more abstract than context-free grammar, and therefore it can be applied to human languages also. While context-free grammar's application to human languages has not worked so far. If we were able to apply context-free grammar to human languages, we would have created human language compiler. But so far, CFG has been able to create only programming language compiler, Java compiler, C compiler, etc., through CFG. But we haven't used CFG to create Punjabi, Hindi, English compilers, right? And Panini was able to apply his grammar to natural language Sanskrit because of another layer of abstraction that he proposed in his model. And therefore, that model needs to be studied more closely, by departments, even outside Sanskrit departments, right? Like the terminal items, if you like English language, words of English language, words of Hindi, any language, words would be there. But in Panini, besides the words, like Devadatta, Odanam, Pachati, Odan, etc., Pachati, etc., there are other sounds also, and dhatu is also part of this abstraction. And production is A goes to alpha. But in Panini, production is always A goes to alpha if C, A goes to B if C. Aka Savarna Dirgha. Aka will become Dirgha only if Savarna. Iko Yanachi. Ik becomes Yan only if Ach. So there's an if then else mechanism of Panini's. Most sutras like that. And another abstraction, start symbol in Chomsky is an utterance. What comes out of mouth. He says what goes beyond is intractable, non-computable, is difficult to capture. What Chomsky says. Therefore, Chomsky in his initial model had excluded semantics from the initial model of grammar. But after 1965, he included semantics also. So, but Panini says the start symbol is not S but S bar, which is vivaksha, the desire to speak. What comes in the brain, and then the whole thing starts building up. So thoughts proceed, and we have to, if we really have to solve this problem of language, we must think about the thoughts also. So Chomsky is much more abstract by several degrees than Chomsky. And I think the West is still trying to grapple with understanding Panini. And Chomsky, if you look at Chomsky's tradition of grammar, which I have gone through more closely, I think starting from 1957 till 1988, or even later, 1990s minimalism of Chomsky, I think he's trying to understand Panini more closely and trying to get closer to Panini. Panini is compared with Bacchus-Knorr form, BNF, which is the notation used for contextual grammar. So if you see, this is how we write, a phrase structure, set of rules for writing the grammar of a programming language expression, So S goes to expression is reduced as NPVP. So Panini's expression is not S, but a pada, P. P is reduced as suptingantam, sup and thing. And so NP goes to det and N in English and English-like languages. But for Panini, it would be sanya pada that will end up in sanya, and it will be flanked by abstract entities. Could be optionally flanked to the left side by abstract entities. Similarly, word phrase will be V and P in English-like languages. And here it would be kriya, could be flanked by abstract entities to left to right. And the noun could be like words in English language. Here could be inflected entities. Of course, there'll be inflections in English also, but here inflected entities are much more in number because of the tight inflection nature of Sanskrit. I did an experiment, how many keywords can you find in a natural language text? So I did experiments on many natural languages, including Sanskrit. I collected 100,000 word corpora of Hindi, Punjabi, Gujarati, Marathi, etc., and also Sanskrit. I found that in a modern Indian language, if you have 100,000 word corpora, you find about 7,000 unique words. But the same thing in Sanskrit will be about 21,000. So in normal Sanskrit text of about 100,000 words, you'll find more unique words because of inflections and or creativity that goes to Sanskrit. So much more a richer language by way of constructions of grammar and also by way of creativity and options to use words in different contexts. And V would be, of course, verbs like in English language, and here would be verbs as well as, the dhatus. And debts will be absent in Indian languages. So Panini to Saussure to Chomsky, Chomsky to computational linguistics and AI. Remember, computational linguistics came before AI, right? So whatever we call AI is essentially computational linguistics. Many people are tempted to say AI as a stepchild of computational linguistics. Now, the idea obviously came from Panini. What is the idea? Describing natural language or programming language, of course. Programming language is a smaller subset of natural language. What Panini did describe the natural language itself. So programming language would be easier task, because if I'm describing natural language correctly, then describing a short language would be easier. Exactly using rewrite rules. What Panini did is describe Sanskrit, a natural language, unambiguously, not 100%, but unambiguously, exactly using rewrite rules. So from Panini to Saussure, Saussure to Bloomfield, Bloomfield to Harris, Harris to Chomsky. Harris was Chomsky's predecessor. He was Chomsky's guru, actually, PhD supervisor, I believe. John Bacchus, the IBM guy, and the Bacchus-Knorr form, and the Peter Knorr and the Bacchus-Knorr form. But people in the West, in this tradition, they knew that it was Panini who actually did all that, and therefore one guy, Peter Zilahi, he did research, and he then concluded that it was Panini who created all this. And he wrote a letter to, ACM, Associated Computing Machinery, and by giving instances that it is Panini who actually did all this. Therefore, he should be given the credit of fathering in this field. And he gave his argument by, doing research in this field. So you must read this article, why, Panini should be given the credit for creating all this. So Panini's technique and abstract tradition used in accurately describing natural language is very similar to John Bacchus, which was IBM employee in 50s, who described a new programming language called IAL, International Algebraic Language, which was actually called ALGOL later on. So John Bacchus, of course, inspired by Chomsky's work, through Harris and through Broomfield, etc., etc. So this is how Panini was reinterpreted by the West. But given this background, what what are the major areas that we do, and briefly just list you these areas that we do in this AI, computational language, NLP. We create input-output mechanisms. They have to be smarter input-output mechanisms. Basically, we give smart inputs to machine through language, through images, through multimodal communications. We get smart output from machines through speech, through gestures, etc., etc. We do taggers. Machines can tag. Machines can word analysis. The word analysis, parse sentences, automatic speech recognition, automatic speaker recognition. Machines can do synthesized speech, read text. Machines can translate. Machines can reference get information from different languages, cross-lingual information access, automatic localization, translation, and summaries of text, and recognizing proper nouns in text. All of these seemingly, some of them are apparently trivial, but they are not actually trivial. They're non-trivial tasks. All of them are very serious tasks. Even a simple pre-processing is very trivial in AI, actually, in terms of natural language. Now, the core thing, the methods in linguistics, which is a foundational discipline here. So in linguistics, we use quantitative, we use experimental, observational, fieldwork, and cooperative studies. And all of these methods are actually included, imported, so to say, in AI and in computational linguistics. So quantitative methods are data analysis, visualization, which is part of the IT. Also, stat is used, a lot of probability is used. Data in linguistics comes from all levels of language use, like sounds, words, sentence, etc. We do experimental methods, where we do experiments on a particular field. We do observational. We observe certain phenomena of language change in users, and by way of interviews and questionnaire. We go to field, collect data, and then come back and write grammars of based on the data. And we also look at corpora, which is an example of language usage, and do studies from there. So if you look at quantitative methods, I don't know how much time do I have, ma'am? But 20 minutes more or something?
Yes, sir. You can continue.
Okay, good. So I'll kind of skip these details. So idea is that all these methods are, if you look at good linguistics departments, like JNU, DU, etc., Hyderabad, I think some researchers will perhaps focus on these methods seriously and train you better in these areas. So data analysis, visualization, stat, probability, machine learning algorithms, etc., are already used in linguistic research. And we do in experimental targeted experiments like psycholinguistics, neurolinguistics. All of them are used in machine learning, actually. And of course, in computational linguistics, we do all of that. Experiments are used in computational linguistics also. And observational methods, we observe the linguistic behavior of a community, and using case studies, using survey technique, questionnaire interviews, etc., etc. And for example, we did dialect geography of Hindi for Mahatma Gandhi Hindi University by using this method. Fieldwork in linguistics, so we go out in field and look at language data, and then come back, use a model like Pandey's model or Chomsky's model, and write grammar of that language. This is how it should be done. And if you look at methods in computational linguistics, NLP, AI, then all relevant methods from linguistics, computer science, stat, probability, programming, etc., all are useful in computational linguistics, AI. And in addition, the methods used in programming in databases. As I said, the nuances, the nuanced techniques and smart methods used in programming language databases are, of course, all very, very important. Otherwise, you'll not be able to structure data nicely. And programs run on data, good data, smartly organized in programs and databases. Then corpora-based techniques, we either have a database structured, or we have corpora structured or unstructured. And from there, we can pull data, either put them in database before processing or process directly using machine learning algorithm. So it depends how you want to take it, actually. And the classical AI technique will pull data from corpora, put it in database, and then our algorithms work from there. In a machine learning algorithm, we directly read from the corpora based on the annotations, and then learn how to actually pick up a pattern from that data. So there is a rule-based and a machine learning-based technique. Rule-based, as I said, if I am doing a rule-based method of AI, I will first build a grammar, and build attendant databases like dictionaries, etc. And then an algorithm. So algorithm, a grammar, and a dictionary. And then I take an input and load the algorithm. Algorithm then says, okay, load the grammar, load the dictionary. And then look at the first sentence of the input text, look at the first rule in the grammar, and then see what kind of words are required by the grammar from dictionary, and then start processing and keep on processing till you hit the dead end. This is how the classical AI happen, right? We have a program already there based on an algorithm, and program requires dictionary and grammar. But in the machine learning base, we don't have a program. We instead give a corpora, unstructured or structured, I mean, annotated or unannotated. We call it supervised or unsupervised learning. And then we have a machine learning algorithm, which can be based on simple statistical methods or based on deep machine learning techniques methods. And that algorithm actually churns the churns the corpora out, but taking several hours, and then learns patterns from the corpora. And then we say machine has learned, and so it has created its program. So based on that learning, which is a program now, it can actually parse new data in its own way. So if I show you a formal grammar, a lexicon and rule, how it works, you will see a parallel of Panini. So this is a grammar which I wrote in 1999, perhaps, when I was parsing English text for database, using classical AI method. So we first define macros, as Panini defines macros, Vriddhi, Radhesh, Adhen, Guna, etc., etc. We define macros. We define diatrans is a macro. What is diatrans? We define start from here, we end here. Full stop. Full stop ends the definition of a macro called diatrans. Full stop, we define vitrans as a macro, like Adhen, Guna, Vriddhi, Radhesh, etc. They start here, end here. We define the akarma kriya, we, etc., etc. Then we use these macros in writing the grammar. So does Panini. Panini defines, Vriddhi, Gun, etc., and then uses those terms, macro terms, in defining his grammar, creating his grammar, his sutra part, right? Similarly, we write, this is our sutra part. We define macros first, this sutra part, and then this sutra part, we require a dictionary. So we write dictionary. And look at this. This is dhatu part. But say, word create. What is word create in our dhatu? It's a ditransitive second person press. These are all macros are defined earlier. Now, how will word create translate to SQL? A create in SQL. Make. So this grammar does additional task. It also translates. Can simply parse. So grammar that our brain has constructed is a smart thing. It learns translate. It does translation also, interpretation and translation. So this is an example how we can create a grammar in the classical AI technique, right? Then I'll also show you how we can construct corpora to train machine in the machine learning technique, right? Now, formal grammar-based lexicon-based methods models. So we have these grammars which are classical, which are used even today in using classical AI, like Ashtadhyayi has been popular, and the lexical functional grammar. These are all Chomsky's children, actually. Bresnan was Chomsky's student, as a lady, and she pointed to many errors in Chomsky's grammar, and then Chomsky modified his grammar based on the comments from his student Bresnan. Bresnan Kaplan did this. Then LFG was grammar given by Bresnan Kaplan. Functional grammar by Martin K. Tree adjoining grammar by Arvind Joshi. Arvind Joshi was Marathi. He worked in University of Pennsylvania. When I had given my talk in 2013 or 14 there, I forget, University of Pennsylvania, he had attended that lecture of mine. I'm so honored to have him in my talk there. Head given phrase structure grammar is given by Paul Arden Sag. And these are all, this grammar is of my particular favor because this is very close to Karakpakam. Karaka. So you see Panini's generative technique and Panini's rule replacement Karaka. It's very interesting. Panini's grammar is so fascinating, it's one of the most mature of all of them, actually. The only thing is how you actually remodel it in the way of AI. That's the deal. Today the focus has shifted to the machine learning based methods and algorithms, and so there's a difference between the conventional machine learning based AI, conventional methods in AI and machine learning based AI. So there is a different lecture note. I don't think we have time to go through that, but I can probably send you this. Basically talks about how a program is constructed, how is the life cycle of program, and what is a conventional AI program, which is non-machine learning based, then what is a machine learning based program, what is how we use machine learning and deep machine learning, and how these things actually work. So I'll send you this PDF. You can go through it. Now, there are integrated machine learning based models which can be trained and retrained. Some of them are pre-trained. Some of them are pre-trained, available on clouds, or we can download some of them. And a lot of these are available: OpenNLP, NLTK, OpenMT, and BERT, Moril, etc., etc. And our own Indian Language Corporate Initiative for Indian languages. And in this, for Marathi, my internet connection is lost, or either my server is down, or something is happening. So this was a 17 language model for Indian languages. From Marathi, our partner was Malhar Kulkarni from IIT Bombay. So India's complex language situation and the technology development is important to consider here. I'm kind of switching to a new topic, because the classical methods in AI, of course, inspired by Panini through Bloomfield, through Saussure, Bloomfield, Harris, and Chomsky, and the modern machine learning methods in AI have been indirectly kind of inspired by Panini. So all of that is important for us to understand, because if we are looking at solving the day-to-day problem of India in terms of language communication and AI, we have to consider an appropriate model. So India's language situation is very diverse, very old. These are our languages. These are our language and scripts. I'm kind of skipping the part where we talk about language complexity, big linguistic data, and our requirements in every field of development: judiciary, administration, education. We are struggling to create dictionaries in all Indian languages. If we create dictionaries in Indian languages, then we create content for education in Indian languages, right? So all of these things are problems that we have to struggle to solve every day in India. So what is critically needed? We need all these basic resources for Indian languages, input-output rules for Indian languages, real-time machine translation, so that we can create, we can teach engineering in Indian languages by translating engineering textbooks in English to Hindi, Marathi, etc. We need machine translation. We cannot hope that humans will translate and we'll have it. It's very difficult. We need text summarization, text simplification, dialogue recognition, multimodal, all kinds of. And finally, we need Indian algorithms, indigenous data centers, and of course, India's own cost-effective, flexible, multilingual AI is very, very important. Current developments: 3 major important developments in India. MIT has, the Ministry of Information Technology and IT, has started an initiative called Bhashini, which is a speech-to-speech machine translation. I'm also in the executive committee, and I'm also we also have a small project from them. Then Principal Scientific Advisor Prime Minister Modi has set up a committee. I'm in the committee there too, for a challenge opening machine translation to startup companies. And we're currently opening up a typical pair of languages in India given to like English to Hindi, English to Marathi, English to blah blah blah, or Hindi to Marathi, etc., to given to a startup company who can demonstrate that they can do it, and then they can be funded. Similarly, Ministry of Education is doing this own initiative at AICTE with the vocabulary of CSTT, which is our commission here, which I'm chairing currently. Among Indian academia, current major players are these: IIT Chennai, IIT Delhi, IIT Bangalore, JNU, CDAC, IIT Bombay, Jadavpur, IIT Patna, etc. Industry also working in different areas. We have Google, currently consulting Google. They have released several translations, including they have done 8 more languages, including Sanskrit also. Google, Microsoft, we have machine translation by both of them. Vision Alexa, which is a speech assistant. They have released Hindi. Siri is a personal assistant in Hindi. I have my student working for Hindi in them. And the Siri and Samsung also has a big initiative. And Google has placed about $10 billion in language technology industry in India, because they have plans to make all Indian languages at par with English in terms of language technology resources. But the startup companies are focusing more in these areas, because there's a lot of resource can be generated, revenue can be generated from these areas, which is a lot of revenue is involved there. So profit is perhaps their legal domain, health domain, and education domain. Because they are smaller companies, they would like to get a lot of revenue out. And so in JNU, on a similar lines, we have done something which could be of a lot of use. So in Sanskrit studies where I teach, I'm currently on leave, but I continue to teach a course in computational linguistics over there, and currently I guide all my students also there. So currently the funded project, as I mentioned, Vidyapati under Bhashini, Hindi to Maithili, and then we have finished these projects, corpora, 70 language corpora, and then machine translation Sanskrit to Hindi. Not a good quality actually, and then language processing for words with Hyderabad University. Consultants is currently consulting Google for making sure Hindi's varieties are also recognized by their speech assistant and their language translation assistant. And nuanced technologies for Kashmiri, Swift key, various keyboards, predictive keyboard. If you are using Sanskrit keyboard, if you have installed a Swift key on your mobile phone from Google Play Store, you activate Sanskrit and you will be using our keyboard. We've done Sanskrit, Santhali, Manipuri, Maithili, Sandhi for them. And handwriting for Microsoft 2006. So this, and I think my talk there was in 2012 or 13, I'm forgetting. And this was for Devanagari recognition on tablet form. And this was multimodal recognition, the University of Pennsylvania. The talk I gave there was in 2013. And there Edwin Joshi had joined. So this 8 languages basically US defense project to them, which was outsourced to me. Idea was that if some terrorist is speaking the mother tongue and crossing through US sensitive places, they can be flagged as belonging to some country based on the mother tongue they're speaking. So you see Pashto Dari also being part of that. And we've done English to Urdu of Bing. I think we have internet here. If you see English to Urdu, Microsoft Translator, you will see JNU's name, which is our name. We did it in our Sanskrit center. I wanted to underscore the point that Urdu is an Indo-Aryan language and we should work in Urdu as well, right? It's Indo-Aryan language. Similarly, I was working on English, Maithili, Sanskrit, Hindi, etc. Languages are being worked on, and hopefully some of these will be launched by Microsoft subsequently. We have our monster tools, which are able to create corpora resources for machine learning for those languages for which we don't have any resource. Our students work on many, many areas. I have 39 PhD students, 39 completed, 41 MPhil students. And currently we are, I have, I think 5 or 8 students more working, and they should be completing research and focusing on currently text summarization. We have Sanskrit text summarization being done by one student. Sanskrit Java interface has been finished. And ASR, automatic speech recognition for Sanskrit, and machine translation, etc. being done. And we showcase every 2 years on international fora. All of them are sponsored partially by Microsoft Research so far. This is our website. You can go to our website and look at some of the tools. I think this might be down right now. I guess, oh, it just came up. Why? So why this program didn't come up, the Indian Language Corpora Initiative? Let me show you. I want to show you this 17 language corpora project. I can quickly show you the Marathi that we did. And let me log in as, oh, Assamese, I logged in as Assamese. Let me log in as Marathi actually. And then I'll show you very quickly a Marathi corpora so that you can see, done by Malhar Kulkarni from IIT Bombay. So this is the corpora that we create is used for training machines. So if I use tag data, I've logged in as Malhar Kulkarni, from IIT Bombay. So you see, this is Hindi and this is translated into Marathi. Script is shared and it's been part of speech tags. This corpora can be used to train a machine to learn translation Hindi to Marathi as well as learn how to tag Marathi. And if I'm not actually disturbing the tag, I can, because it's a live server. Let me going to show you very quickly the chunking part. So if I load the same sentence, our chunking interface here. So I'll load the same file. And so if I load my chunking interface, so chunking interface basically we identify from which part forms a natural chunk in the language. Now this data can be used to train machines how to identify naturally, recognize these natural language structures in text and also be able to translate automatically. So I'll not. So this, I mean, you go to my website and see. So finally, our progress today depends on AI. It has evolved in terms of the computing power that AI has gained, and also the methodology that AI has changed constantly from the classical methods to newer methods. So we have to be aware of the changing nature of artificial intelligence today, in terms of computing power, resources, and also the changing methodology. So that any AI model that we evolve for India should be, long lasting. It should not, become useless. And we need this model in areas like governance, education, health, disaster, any area in the language, literature, culture, areas. But we need to create resources in these languages, and we'll have to work on creating common core, which is Sanskrit-based common core, because we cannot write programs for all Indian languages. We'll have to have a common core called Sanskrit plugged in all Indian language, because Sanskrit shares vocabulary with all Indian languages. Sanskrit shares grammar techniques with all Indian languages. Therefore, it makes much more sense to have a common core Sanskrit plugged in with all of them. And that will reduce our cost. That will reduce our cost and reduce our efforts, And then work on educational technology, India's own AI and our own AI data centers also. So challenges are diversity, paucity of standards, language variation, mixing, etc., funding, casual approach, lack of teamwork, lack of competition, and complexity of natural language, more so in multilingual societies. So there is a challenge for using AI in India. We have our linguistic cultural diversity, and second most important challenge is using AI itself. The AI has changed phenomenally from the classical period in 90s to today, because as I said, when I did a course in artificial intelligence in 1997 in University of Illinois Urbana-Champaign, it was called a course. It was titled Introduction to Artificial Intelligence, but the course actually was programming in Lisp and Prolog. If you do a course in AI today, it will be programming in Python, but machine learning and deep machine learning primarily. So AI has changed phenomenally. So you have to be aware of that. So thank you very much. I had a great time talking to you. I hope I have not extended my talk too much, and we can now perhaps take some questions. Thank you, ma'am. Thank you so much.
It was brilliant exposition, sir. We will see if there are any questions. Any questions?
Rajesh, you can ask.
Yeah, thank you, sir. It's very, very interesting lecture. Despite being Sanskrit student, I didn't knew so much things are already happening. Anyway, the point that I would like to know so far as the Paninian grammar and its utility in AI is concerned, is it at an experimental level, or it is fairly catching up globally?
Yeah, good question. See, the West has been very, very smart. They have done successive translations of Panini's grammar. If you read the contributions of 19th century Indologists from the West, they have done translations of Panini's grammar. So they have, understood Panini's grammar from a different perspective and given that to the West, and West has evolved using that in AI. Now, what has happened, that in Indian language departments of linguistics and primarily Sanskrit, we have not benefited from that translation. We have taught Pandey from two perspectives, from the Prakriya perspective, Siddhant Kaumudi, and from Pandey's own perspective, which is Pandey's own Ekvakyata perspective. But we have not looked at the AI perspective or the linguistics perspective on Pandey, which I showed you, the four modular approach that the West has obtained. So there needs to be a greater demand for close interaction. West has taken a certain view of Panini, but has not gone deeper into Panini. So there's a lot more that they need to know in Panini. You have the most minute details of Panini, but you do not know the Western method. So there's a lot of interaction possible. And therefore, I will call for international collaboration between Sanskrit departments and the Western linguistics departments and AI departments, and even Indian departments, so that a lot more can happen. I would say it's actually at an experimental stage in India, but slightly more advanced stage in the West.
Oh, that's very interesting to know. Thank you, sir.
There is one question in the chat box. Sir, can you guide where NLP can be learned?
Well, there are a lot of courses. NLP is the most popular happening right now. Look for NLP courses, there'll be tens of courses coming down. But, to start with a basic course, I think you should first do, if there is a certification program in NLP, you should do that first. And then I would say to do that, you'll have to do linguistics. So do core linguistics first. You have to do syntax and semantics and morphology and phonology, 4 major areas. And then you do some certification in the methods of NLP, and then be prepared for a full program in NLP. That's what I would recommend, actually.
There is one more question by Manjiri. Manjiri wants to ask. Manjiri, please unmute yourself. Manjiri, please unmute yourself.
Hello.
Yeah, Manjiri.
Yeah. I wanted to ask, can assembly language be designed in Sanskrit? And what are the exact areas in which research can be done related to Ashtadhyayi?
See, any language being designed in any other language, this whole idea, I mean, see, the whole goal is that can natural language be used as an artificial communication in machine language? That should be the goal. And as an experiment, yes, theoretically possible, yes. But then as an experiment, my student who did PhD recently, what he did, he took Java's API, like, java.lang, basic lang, and implemented certain aspects of that using Sanskrit. So you can give a command in Sanskrit, and what gets compiled is Java. So basically what you have to do, have a translation procedure at this point, Sanskrit to assembly language. Theoretically done, but the question is utility of it. Unless we have full-blown parsing capacity of natural language directly into machine, it will not be very, very useful. Like my student did, Sanskrit to Java. Essentially, I'm compiling it in Java, right? So what the machine is understanding is Java, not Sanskrit directly. But I'm doing Sanskrit transformation to Java. I'm kind of interfacing with Java. So my goal is that we should directly communicate with the machine in natural language, and that is the goal. Still, being done, practiced by many experts in this area.
Yeah. Okay. Thanks.
Thank you. This is Ramakrishnan speaking. Can I ask a question, sir?
Yeah, please.
Yeah. See, India seemed to have lost that AI race to the West, given that we had a knowledge base of the Ashtadhyayi and the Sanskrit tradition a long time ago. So what are we doing to get the Gurukul involved? Because I'm sure a lot of embedded knowledge is there in the Gurukul. The domain knowledge is there. So how do you bridge that gap of getting that knowledge out to the research community? Because the domain knowledge is already there with us. So somewhere we seem to have not leveraged to the maximum extent possible. So what are the efforts in that direction?
Exactly. I think you've hit the I would say bullseye. See, Gurukulas are our traditional strength, and unless we strengthen that system, what has happened? The Gurukula pass outs, when they come to universities for higher education, because the jobs will be only when you do modern education. Like my father, when he did Acharya, when he went to do more studies, he had to do MA in Sanskrit again, and it was a repetition of the whole thing, right? So then he could do PhD, because only MA was recognized as the basic qualification for PhD. So unless we kind of do a complete rehaul of the system, I mean, fortunately, the national education policy has brought in all those things, and has put in so many things. But we have to get a lot of funding to the Gurukulas and make them directly interface with the AI centers and India's own AI centers and linguistic centers. And I've also recently we had a meeting of Sanskrit vice chancellors at the high level power and the committee for Indian languages. I was there. I recommended that we should modernize our curricula and make sure Sanskrit's isolation is ended. There's a lot to benefit from interacting with people, and our people are very smart in domain knowledge, very, very smart. When I interact with my colleagues in Sanskrit Center, see, the reason I joined Sanskrit Center in JNU was that because I will be getting more knowledge from, I have done Sanskrit BA, but I needed more knowledge from my colleagues. I get fascinating knowledge from my colleagues because they have read all the texts, and I can use that knowledge, So it's very important that our knowledge is used by our contemporary disciplines. Therefore, a lot of interaction, close interaction is necessary. Yes. And we have to succeed in that area.
Yes. Yeah, I'm sure that you would have read that book on the battle for Sanskrit. And we should ensure that it doesn't happen that we lose out on the Ashtadhyayi and the artificial intelligence part. It's at least we need to ensure that we don't repeat the mistakes of the past.
I think I was in that the launch program of that book, Rajiv's.
Yes.
So yeah, it's quite good. Yes, we have to do it. We have to be very, very meticulously planning our strategies. And so what is good for us? If Panani is good for us, yes, use it. Why don't our linguistic departments use Panani if it is good? Why waste time in doing Chomsky, which doesn't work? Even
Exactly.
Chomsky it doesn't work even for the West. And we are so fashionable. We want something anglicized with English names, etc., etc. I mean, this is insane. This is crazy.
Absolutely. Thank you, sir.
So,
is there any question? I think there is no question now. Thanks a lot, sir.
Thank you.
On behalf of Sanskrit Department, University of Mumbai, I thank you for delivering a lecture on Sanganakiya Bhasha Vigyan mein Pravidhigata Navachar. Your speech was really thought-provoking. The topic which you have chosen was very interesting. You put it forth in simple and lucid manner. The site which you have given today through your lecture will surely help our students while studying Sanskrit grammar and linguistics. I thank you once again. I thank Rohit sir for providing us with Zoom facility. I thank all participants. Tomorrow we shall meet again at 3 p.m. to hear to our own Shruti Kanitkar speak. Thank you.
Thank you, sir.
I request everyone to start their videos so that I can take a screenshot. Thank you.
And tomorrow's session will be more interactive. So prepared with certain questions because Shruti Kanitkar will be telling you about her journey towards writing a poem Srimati Charitram Mahakavya. But of course, she said that it will be more interactive. So if you ask questions, she will be answering you about certain things. So be prepared with that. Okay. Thank you so much.